Thank you for joining us today. We are certain that you will find your time well spent. Preventing fraud in the communications industry is an ongoing challenge. Chris Pinion and Nicole Domeyer are part of a devoted team at LexisNexis Risk Solutions developing fraud solutions, and they will share with you how you can actually do less with more in your efforts to prevent fraud. Please feel free to use the chat feature to submit questions that Chris and Nicole will answer later in the presentation if time permits. If we don't have time to answer all questions, Chris and Nicole will personally respond after the webinar. Also, please participate in the polling questions. We value your feedback. As a reminder, this meeting is being recorded and will be sent to all attendees. So let's get this started. Chris, I'll turn the call over to you.
Hello, everybody. My name is Chris Pinion. Thanks for joining. Wanted to go ahead, just a quick agenda for the presentation that we'll be going through today. As we discussed, the challenge of fraud detection and PII in the communications industry is going to be the topic of our discussion today, and being able to get a better understanding of how you can do more with less. We're going to talk about, Nicole's going to cover a study that LexisNexis has conducted to give you some ideas on ways that you can use some different modeling techniques to be able to identify more fraud and how you can do more with less. And then we're going to talk briefly about LexisNexis's Fraud Point solution, which is the solution most customers are looking at using in trying to prevent fraud. So real quick, for those that may not be aware of LexisNexis and who we are and what we do, LexisNexis is a data company. We're a data company that has data sources that we compile information from. We compile information from 10,000 plus data sources that allows us to provide data and analytics solutions to our customers. Those solutions enable our customers to make faster, better decisions for the customer base that they support. We serve a lot of different markets. We serve the collections and recovery market, more specifically to the group here, the communications, mobile, and media market. We also work with the financial services market, government market, and other markets that also include healthcare, e-commerce, retail, just about any type of market that you can think of that would need any type of identity verification and fraud prevention solutions. So what is it that LexisNexis does? Okay. LexisNexis, we're able to go ahead and accept and process all those 10,000 different data sources and data assets that I mentioned. And we're able to process that in a fast, efficient way using our proprietary HPCC systems technology. Well, we're able to process all of that information. We're able to go ahead and take this data and link it to all of the different data sources that we have internally, making sure that the right data that is being brought in from all of our from all of our different data sources is being brought in and linked together, and making sure that the right data matches the right person or business is important. Our LexID technology is really the glue that holds all of this information together and allows us to provide a lot of the different customer-focused solutions that we're able to go ahead and provide. Now, a lot of our customers and a lot of folks like to go ahead and get a better understanding of the different data assets that LexisNexis has available and that they get to go ahead and access. And this is just a quick little snapshot to show you all of the different data assets LexisNexis has available. You'll see here we have insurance records, consumer records, 10.3 billion unique name and address combinations, property records, motor vehicle, bankruptcy, vehicles, quite a lot of data that our customers are able to access in real time to be able to make those decisions that we discussed. So what are some of the different customer-focused solutions that we can deliver? Our customers look to us to provide identity management solutions, allowing them to be able to validate and verify identities. Fraud solutions, for obvious reasons. Fraud is constantly changing, and being able to stay on top of the new trends to be able to protect against fraud is something that most of our customers are looking to LexisNexis to help them provide. Compliance solutions. Staying in compliance, reducing financial or reputational risk is key to any business. Investigations. Investigation solutions help you discover links between people, assets, and locations when needing to do additional due diligence. And then data management allows our customers to use the data assets that LexisNexis has to be able to give them some insight and have a complete view of their overall customer. So today what we're going to talk about is the challenge of fraud detection and personally identifiable information, or PII. Traditionally, the fraud scoring process has looked at things like being able to, there's been a certain process that's been in place. Right? You take the consumer PII and you try and find the right identity to see if there's any types of issues that you might want to concern yourself with. When you're able to find the right identity, you look to append identity elements and application information. We take all that information, put it into a pot, kind of stir it all up. You have a score that will come out, and that fraud score, much like a credit score, will go ahead and allow our customers to make decisions on whether or not we believe there's fraud being perpetrated or not. Traditionally, fraud scoring models have used things like your first name, last name, address, phone, social security number, and date of birth. And most fraud models have been built on this data. However, nowadays, you've got other types of data that are also kind of being brought into the mix as we continue to evolve. And you have things like work cell phones, email addresses, IP addresses or device IDs, additional phone numbers, or the potential for a second identity. Right? So all of this different information that is out there that customers have to deal with to try and identify and predict the likelihood of fraud, there's so many different categories of information that you can use to do this. However, using all of this data might not be as feasible to be able to use. Hence the title of this presentation, How Can You Prevent Fraud in the Communications Industry by Using Less to Do More?
All right, perfect. Time for the first poll here. Which types of personal identifying information do you require upon account opening? If you guys could answer the question for us today. We do have a couple answers here that you can select. Name, address, phone, email, social security number, date of birth. Give us a couple seconds here while we collect information. Nicole, it looks like here, after closing the poll, that name and address definitely got 100%. What do you see in the results there?
Yeah, that's great. Thank you, Toby. Yes, so what you all have just demonstrated for us here is that you all like to collect, or maybe not like, but you will collect name and address, but some of you don't collect other pieces like social or date of birth or phone number. So that really gets to the heart of the problem we want to talk about today, is that requiring all of that PII information we just asked you about may not be desirable or possible depending on policies or security concerns. But most traditional models often expect that you have full information, and beyond expect, most statisticians will tell you, give me everything you've got, right? Because then I can do the best that I can. The more information I have, the better I can do. So what we're trying to do is really balance out how do we meet that requirement where you don't want to collect all of the PII information because it causes customer friction or there's customer concerns or security issues without ultimately sacrificing your ability to identify fraud. And as we started to dig into this problem, we wanted to understand really, so what are our customers sending us, right? How big of a problem could this be? How often are we not getting full PII information? So here I'm just showing you a set of transactions from 1 month last summer from customers in the telecom industry. And here we see that only 11% of those transactions actually had full PII information on it, right? We had first and last name, address, phone, social, and date of birth on 11% of those transactions. The vast majority were missing date of birth, and then a few other combinations snuck in there, with other combinations. So digging in a little bit further, we see too that most of the time name, address, and phone are provided, and even that lines up with that poll question that we just asked for most of you. However, social and date of birth are the most likely things that are not collected and are not sent to us. That makes sense given some of the security concerns. And when I look at that, what I see is that now we're missing social and date of birth, so we're unable to append any information relative to the risk around those things. For example, without having the social provided to us, we can't check whether that social was issued prior to the date of birth for that individual, right? That's a key fraud indicator. Another thing is that we may not be able to link quite as well to the individual in certain situations. One example I like to give here is, think of a junior and senior, right? And junior's still living at home. So the name and address look identical on that application. So the only thing that might help us distinguish between the two and really accurately assess that risk would be a date of birth or a social, and if that's not provided, we miss some of that information. And as we look further, speaking about this from the LexisNexis point of view, a lot of our fraud content kind of falls in these two big categories. We have identity information, where we've done our job, we've linked all these great sources together, and we can look at a broad history, and we can look at their relatives and associates. And on the other side, we have things tied specifically to that application. So there we're looking at those input elements to try to figure out how they blend well with the identity that we've picked out, as well as just general risk for some of those things. To give you a few examples from that application set, think about just something as simple as validation, right? Does that social look like it is a valid social? Are they using one that, maybe it's a pocketbook social, right? Those little slips of paper you used to get in wallets that had a fake social on it, right? We check for those. Various other things like velocity. We like to check for whether there's been inquiries happening relative to that address or that social. Right? And that may have nothing to do with the identity or the person actually sitting there and applying for your product, but it could be indicative of somebody else maybe using that address or that social. So those are sorts of things that we like to look at from the application side. When we don't have that PII on input, a lot of that content starts to go away or degrade a little bit. So let's talk scores a little bit. So here is a distribution on a set of transactions from a score that was modeled where we had full PII information to develop that score. And here, just a little background on the score range. So a low score is high risk. That's where the fraud is, or that's where we hope we've put the fraud. And a high score is low risk. So you definitely want your fraud down in that lower tail. Now, once we start taking this model that was built using full PII and start applying that to other sets of transactions where they don't have everything, what we see are some pretty major shifts in that score distribution. So you see all of these curves that start to push downward into that lower risk score range, or the higher risk score range, making it more and more difficult to discern between a good and a bad record. And that farthest one we kind of called out, that is where the customer sent name and social only. That's where we see kind of the biggest downward shift. So digging into that a little bit further, what I'm showing you here is that average change in score when we apply it to these different profiles. So I have all these profiles here marked by an abbreviation here. So you got F for first name, L for last name, A for address, P for phone, S for SSN, and D for date of birth. Just so we can kind of mark here which PII elements we're starting to lose. So we wanted to look at this. We wanted to look at the average change in score, beyond just seeing that score shift, to really understand, on average, what is really happening, and are there certain profiles where we have, a bigger problem. So if we look at that very first red bar on the left side, that is a first, last, address, phone, and social profile. Right, so we're missing date of birth. So you see there the average change in score is kind of minor, meaning that date of birth maybe didn't have that big a role. When we're losing that, on average we're losing a couple of points on every record. But as we start to progressively move through those other profiles, losing more information, we saw a couple of patterns emerging. The first thing was that address and phone seem to be the biggest contributors to a massive score change. So if we look at, for example, the next set of 4 bars there, so it's starting with the FLAPD model and down to the FLAP profile, those 4 there, they're starting to lose some information, and the middle 2 there, we lost phone. So you see this big drop down where now, you're going from losing an average of 10, 12 points, now down to, 20, 25. If we move over a few bars, and now we're looking at like that FLAD profile, now we're getting closer to an average drop of 40 points. And there, we're again missing phone on that profile, which is getting a big drop. That, in conjunction with the social, is what's pushing that far down. If we go very far to the right, in those last 2 bars, the FLSD and the FLS profiles, there we've lost both address and phone. And now our average drop in score is 60 plus points, which is a pretty massive shift compared to what you were expecting when you originally built the model. If we talk about this in terms of real impacts to our cutoffs, let's take this scenario where we built a model using full PII. At that time, we looked at the distribution and we said, okay, let's set a cutoff at 600. Everything below 600, we're going to review those and try to identify the frauds. In that case, we were reviewing about 5% of transactions. That was our tolerance for volume. And in that set of transactions, we were achieving a 16% fraud rate. So we were actually able to identify quite a bit of fraud. Now let's say that we change our input policy, and now we only give name and address, which actually is in line with that polling question we asked a little bit ago from all of you. Now we see that volume in that review queue jump up to 30%. That's a pretty sizable increase. Along with that, we see that the fraud rate jumps down to 10%. So not only are we reviewing more, but we're reviewing more good records and less bad records and now we're not able to capture all that fraud that we want to catch. If we look at that across multiple profiles here, so let's start with that bar far on the left. So we're looking at this model that we built that took in all of the PII. At that time, we predicted a volume of about 50,000 records out of 1 million. That was what our cutoff was when we built it. Now we start shifting our policy around, and as we start doing that, you see that volume creep up and up and up. So there's a lot of movement in our review queue in terms of volume, and that can be fairly meaningful. Similarly, we see a big shift in our ability to catch fraud. So again, if we start at that left side, we were expecting a 16% fraud rate from the model that we built that expected full PII. We start changing our policy, and you almost get this like staircase effect here where you see big drops in the fraud rate in our review queue, all from just changing that PII policy without changing anything in the model. Because that model is expecting all of that information to be provided, and when we don't get it, things start shifting around. So what that means here, so if we look at the cutoff, this is a perfect world. This is our expectations where we built that full PI model. And here I'm showing you, so you've got the curve that has the score distribution, and I'm showing you populations below and above the cutoff. So below the cutoff, you see that balance between frauds and goods there, where there's a pretty good-sized chunk of frauds. You still got goods in there. We know that that's the case. When we look on the flip side, above the cutoff, we see that the vast majority of that set are good records, right? This is that balance that we want to achieve. And that is in our situation where we're meeting expectations, we're sending exactly what the model expects. When we start changing that policy though, what this is showing you is that we start to change the amount of fraud and the amount of good records below that cutoff. So you see that all of the frauds are dropping off, right? They're moving out of that cutoff region, and goods are starting to creep in. Right, so your fraud records are starting to score higher, crossing over that cutoff threshold. Your good records are scoring lower, and they cross into that cutoff threshold because we're no longer able to distinguish quite as well between a good and a bad record because we're missing information. On the flip side here, this is a view above the cutoff, and you see big jumps in the amount of fraud that's creeping in there. All part of that same problem because they have to go somewhere. If they're not below the cutoff, now they're going above. So it looks like we're ready for our next polling question.
Thank you, Nicole. This question is the need for a better customer experience affecting the PII you require for account opening in various channels, i.e. mobile, online, in-store, etc.? If you could answer yes or no on this polling question. Give it a couple seconds here while we collect the answers. Now, Nicole, it looks unanimous here. Got 100% yes.
Yes, I see that. That's exactly what we expected. So I've just really laid out sort of the problem, right? What's the problem with starting to collect less? Now I'm going to walk through, how do we fix this? Can we do more? The answer to that is yes, we can do more. So you really have 4 options to kind of deal with this. The first one is not an option that anyone really wants to go with. That's sticking with the status quo. Send what the model expects. So if you built it using full information, send it full information. As we all know, that really inconveniences customers, causes us a lot of problems. Option 2, You could adjust the cutoff so you review the same problems. Remember when I was telling you that when we started changing that policy, our review volume went from 5 to 30%? You could change that 600 cutoff number to be, say, 500, so you're still reviewing that 5% that you want to. However, you're really now decreasing the amount of fraud that you can catch. But maybe you don't have a choice with your fixed budget, right? That's one option. That at least eliminates the review queue problem. However, it does not eliminate the risk dilution problem. You can also go with option 3, where you review everything above or everything below the cutoff. So you keep that 600 number, you deal with the 5 to 30% volume increase, you hire more resources. Not optimal, right? You're still at least catching a lot of fraud, but now you're still dealing with that massive volume increase. Our solution is really to build multiple models accounting for the different PII profiles you think that you might be collecting. It takes more time to develop, but you certainly get a better result and a more stable result. You can think of it this way. Everybody loves cookies, right? And if you think of a fraud model as a recipe for cookies, right, you know that the recipe expects a certain set of ingredients. And if you start to take those ingredients away, you end up with really bad cookies. Sugar is a key one, right? However, sometimes you don't have a choice. My cousin, in fact, is allergic to processed sugar, so she has struggled on her love for baked goods and how to get that without having sugar. She finds that honey is a good substitute. However, it's still not exactly the same as sugar, and it's still not exactly the same recipe, but at least it's a workable cookie. Our approach is very similar to that. So what we did in the latest version of FraudPoint, we took a pooled cross-industry sample and identified a subset of those records that had full PII on input. Then we started to systematically drop out different portions of PII so that we could get down to the commonly occurring subsets. There's actually 12, the 12 that I've kind of been reviewing in earlier slides. Here, this graphic only has about 6 of those. And we trained a model on each of those different subsets so that we could compensate for the missing PII. So rather than building it on that profile on the far left that has everything, you've got name, address, phone, social, date of birth, we built one on every single one of those profiles so that if we would drop out social, like that second column there, the address and the phone and the date of birth content could start to compensate for that missing information, because that model is still going to optimize its ability to find fraud. It's going to try to make up some of the difference. So let's look at how that handles, or how that solves some of the problems we were seeing before. So this is the same view I showed you a few slides ago, where we took that model that was built using everything and applied that to all of those different profiles, and we saw these big shifts in review queue volumes. When we built models on each of those 12 profiles and applied them and looked at their review queues, we saw a lot more stability. Right? There's still some fluctuation there, but it is far more stable when you build a model for each of those profiles and it can do what it can do for that set. We see a similar level of stability here when we look at risk dilution. So again, here's that stair step down where we're finding less and less fraud as we look at those 12 different profiles. When we build a model for each one and look at how well are we able to find fraud in that cutoff, now we see that stabilize. One caveat. So here it's certainly stabilized, but there's still a drop down, right? We're still going from roughly a 16% fraud rate down to maybe 10 1/4, thereabouts, in that far left profile there, which I think is first, class, and social. So without having that information, there's still pieces missing that we're just not able to account for with the information that we do have, right? Similar to putting honey in instead of sugar, you get a good cookie, but it's not the same cookie, right? So here, one thing you can do to kind of handle some of this risk dilution is maybe you can supplement with some passively collected data, right? There might be something else Chris definitely covered some of the additional supported inputs, maybe device ID, maybe something else, something that doesn't impact customer experience that you already calculate that we can maybe tie some content to. Maybe that could make up some of the difference. So just to kind of recap and cover our recommended steps here. So when you send a model, when you build a model using full information and then you start to send it less, you definitely see that model degrade in its ability to find fraud. You see some massive shifts in your review queue. However, if you identify the profiles that you think you're going to be able to collect, and maybe those profiles differ from channel, you can build a model on each of those different profiles so that you are maximizing whatever you can get out of that situation and try to recoup some of that difference. Add to that some passively collected data, and you can really push that needle further. And with that, Chris, I'm going to let you take it away.
Yep. So thanks for going over all that, Nicole. I think there was a lot of really great, insightful information there that hopefully folks are able to go ahead and take away and do some analysis, or at least have some discussions internally with some of their constituents with. So I think that was some great information. So I wanted to mention to you, at LexisNexis we have a solution called FraudPoint. Our FraudPoint solution is really the tool of choice that a lot of our customers use from a fraud and scoring analytics perspective. One of the things, just as a quick reminder, I talked about all the different data assets that LexisNexis has available, 6 petabytes worth of data. One of the things that makes Lexis unique and really powers our FraudPoint solution really is our data assets. LexisNexis does have a lot of really cool things that you have access to. We are the only company in the country that has access to the identity records from all 3 credit bureaus. We're able to collect information from a lot of different business associations, phone records, national coverage of all your state, local, and federal government records, driver's license record, contributory databases, college attendance, accident reports, emails. The point is LexisNexis, with all of the different, not only the sheer volume, but the types of data assets that we have available to the solutions that we build, we're really able to provide you with that complete view of an identity to look for fraudulent activities, patterns, and behaviors. So our FraudPoint solution, we do have, it has 2 components. Really, we do have our FraudPoint attributes. These are model-ready attributes that our customers can use to either build their own model, supplement fraud models that they may have already built. But these are all model-ready attributes that some of our customers will go ahead and consume. We also have our FraudPoint score. We have an off-the-shelf model of a score, but we also find, to Nicole's point and kind of the point of the presentation, that we're able to go ahead and create custom models that typically will perform a little bit better on the customer portfolios. But we do have a FraudPoint off-the-shelf model that we do have available that our customers can take advantage of, along with that score, as Nicole mentioned earlier. The score range that goes from 300 to 999. The lower the score, the higher the risk, or the higher probability for fraud. We do also return back 6 fraud index classifications. So we're able to tell you what type of fraud do we believe is being perpetrated on this application or at the time of the new account opening. Is there a high probability of this being a synthetic identity versus a stolen identity, manipulated versus a vulnerable victim? Okay? And at the same time, we'll also return back to you warning codes. So here are some of the top reasons that an applicant's fraud scored the way that it did. And just to give you, because I'm a visual guy, an idea of what that might look like, right? We've got our fraud scores. You can see the lower the score, the higher the potential risk. You look at those fraud risk indices, right? There might be a higher probability of a stolen identity, and those typically look a little bit different than a synthetic identity. So being able to understand the type of fraud that might be being perpetrated allows our customers to help direct the type of fraud investigations that they may conduct, might help direct them in a fashion that will allow them to ask for certain materials to further their due diligence process, as well as the examples of those warning codes that are there. An example of some of the warning codes, there's a high velocity of identity events that might be associated with an application, or there might be some different address discrepancies that might be there. So that's just a quick summary of our FraudPoint solution. I don't know if the chairperson is able to advance the last slide. For some reason, I've been disconnected. Toby, I don't know if you're able to go ahead and do that.
I went to the detecting and quickly investigating identity fraud slide. If you'd like to pick up there, or if you would like to go to Q&A, that would be the next slide.
Yeah, the last slide there, slide 41, I believe it should be. So that slide is really just a slide that outlines and gives you a quick definition of some of those fraud risk classifications that I mentioned that we're able to go ahead and return. A lot of folks just like to get a better understanding of what those mean. So wanted to provide you that quick definition. So that was the last slide that I had. So I think we were going to go ahead and kind of turn it back over to the chairperson to go through our last polling question.
All right. Actually, we have a question slide next, and then the polling will come last here after a couple questions. As a reminder to everyone, if you do have a question today, please use the chat feature in the lower left-hand corner of your screen. We did receive a couple questions here. First question is, ease of implementation is key for any solution I put in place for fraud. Doesn't this additional training of the model on different PII elements prolong the time it takes to implement? How long does this approach usually take?
I will take that question. So yes, it certainly does take a little bit longer. However, for our approach, we built 12, right? Because we are putting out, we're trying to service all of our customers. But we might be able to do custom solutions where maybe you only need 2 or 3, because you know for sure you will only ever take these three different profiles. So that can really cut down that time. However, you have to ask yourself, is that additional training time worth it to you in order to prevent that fraud? Because in my opinion, it would be.
All right. Next question. How many different profile variations on input PII can FraudPoint handle? Are certain combinations of PII more effective?
Oh, that's a doozy. All right. I will take that one as well. So as I said, we built to support 12 different combinations. As far as effectiveness, for our content, we found that address carries a lot of weight. So having address in the combination certainly seems to improve some of our ability to catch fraud. So I would say probably address and social are fairly important in there. It's difficult to really answer that effective question, at least with the information that I have in front of me.
Thank you, Nicole. Another question is there a big difference between full Social Security number and last 4 of Social Security number?
Chris, go ahead and jump in and add if I don't catch it all. But as far as I know, we are able to accept a 4-byte social, just the last 4. And we are able to get some content through there. Chris, do you have anything to add?
Yeah, I was going to say, and I apologize, I was on mute. So I think one of the things that makes Lexis a little bit unique is our ability once we receive an input record. You have name, you have address, if you have full social or last four, right? Kind of all goes back to that LexID technology I talked about at the beginning of the presentation. When we're able to go ahead and narrow it down and find the right LexID or the right identity profile for us to do kind of apply all of the scoring algorithms and the attributes that Nicole kind of talked a little bit more about. When we're able to find that right identity and apply all of that statistics and all the analytical information to that identity, that's really the key that's there, because once you find the identity, understanding all of the patterns, activities, and behaviors associated with that identity is really what helps kind of predict the fraud for that application. So having full social, that's something that can definitely help us narrow down our search for the right identity. However, last four certainly will definitely help. Full social is the best, of course, but because of our linking technology and the way that we're able to ingest a lot of different disparate data sources and link them all to one record, it's not as important to have the full SSN9 as it traditionally was in the building of previous models. Would you agree with that, Nicole?
Yes. That's a much more eloquent answer than I gave, Chris. Thank you.
No problem.
All right, thank you, everyone. Looks like we are coming up on the end of our time, and we know your time is valuable, so we will let you get back to work. Thank you again for joining us and for your participation in the polls and sending in questions. Today's presentation is available for download by visiting the link in your chat box, and a recording will be sent to all attendees. Preventing fraud is critical to your business, and LexisNexis is available to continue this discussion with you. Just click on Yes if you'd like a LexisNexis rep to follow up with you. This does conclude the webinar for today. You may now disconnect your lines.